All right, we are going to go over some sample questions involving DeMorgan law and the distributive property. All right, so here's your first one. Pause the video, see if you can make some sense of it. All right, I highlighted this part because that's where I would start. I would start on the inside and work my way out. All right, so the key to this is to realize that not A not equal to B really is the same thing as A equal B, right? So if I combine these two knots right here, I get A equal B, okay? And, sorry for the weird parentheses, and B greater than 7, okay? And now we're going to use DeMorgan, right? Now that we've cleaned that up, now we're just going to distribute the knot inside of here and then change it to OR. So if we do not A equal B, we'll have A not equal to B, or switch the sign in between, and then not greater than 9 is less than or equal to 9. That's the same thing as like not greater. So that should get us letter B, right? So if we do DeMorgan properly, distribute it, and then switch the sign in between, and then change these two to their reverse, we get letter B. All right, next one, again, pause the video and see if you can make sense of it. All right, so this is asking about testing this method. And we want to test, basically we have three paths, an if, an else if, and an else. Okay, so we want to test all three of these possibilities. All right, and so we want essentially each number to fall in one of the buckets. So basically if I go through and look at letter A, 8, so if we do 8, the remainder when you divide by 2 is equal to 0. So 8 would fall in this bucket. Then let's test 9. 9 is, the if is false. It's not, its remainder is not 0. 9 is not greater than 9, so it won't go here. So it'll go to the else. And then if we check the 12 will actually fall in the first bucket with the 8. So that does not test all the possible paths. It just tests the if and then the else, not the middle path. Okay, so let's try the next one. So 7, its remainder when you divide by 2 is not 0. It's not greater than 9, so it's going to fall down here. 9, remainder when you divide by 2 is not equal to 0. It is not greater than 9, so 9 is actually going to fall down here also. So that one's out because we're not hitting all the buckets. All right, let's try the next one. 8 we already talked about falls in the first bucket. 9 we said I think falls in the last bucket. And then 11, so 11 mod 2, its remainder is not 0. It is greater than 9, so it should fall here. Right, so it looks like C should be correct. Right, and if we're not sure, we could test the other ones, but I think like on D, 11 and 13 would both fall in this bucket. So D is not right, right? So you can go through and check if you really want to make sure, but looks like C should be the right answer. All right, again, pause the video, see if you can make sense of this question. All right, this one is our distributive property because we actually have three statements like A, B, and C. And we have an OR on the outside of this AND. So we're going to distribute it. And so we're going to get this thing or this thing and this thing or this thing. Okay, so if you look at that, we know it's like an AND between them. Right? It actually means only E and A are left, and it's actually going to be A. So this one or that statement, and in the middle, this one or the last one. Okay, so that's just the distributive property, just kind of a different version of it. Again, this is what it might look like on the AP test. All right, so this one ends up being a pretty tricky one. And so if you're stuck, you can do a truth table. So it says X and Y are Boolean values, right? And then which of the following always evaluates to the same value as the expression above. So which one of these is basically equivalent to the statement up here? Pause the video and give it a shot. Okay, so if I read this thing, this is X or Y and the statement X. All right, so a couple of things to note about this. When you have an and, you have two parts. So basically, if X ends up being false, this whole thing is going to be false, right? Because anything and false is false. Okay, also, similarly, if X is true, then this whole thing is going to be true because you'll have true or whatever Y is here, but this or is going to be true because the X is true. So we're essentially going to have true and true, which will be true. Okay, so more or less, this is actually the same thing as X, right? Because if X is false, this whole thing is false. If X is true, this whole thing is true. So it's really equivalent to statement X. And if you weren't sure, you could build up the truth tables and verify that is indeed correct. Okay, and if real quick you want to see this, so our cases again would be true, 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 false, false, true, and false, false. Okay, and then I'm just going to build from there. So we need the or part of this. So this would be true when either one is true. So look like that. All right, and then we're going to come and that with the X. So I'm going to take these two columns and them together. So this would be true, true, because they're both true. And then false, true would be false. False, false would be false. So we can see that what we end up with here is actually the same thing as our X column, right? It has the same truth values as our X column. So that's what they're saying, is that these two statements are really equivalent because they have the same truth values. All right, last one. Pause the video and give it a shot. I'm going to start with DeMorgan. I'm going to clean this up a little bit because this not we can apply. So I'm going to keep the first part the same, X and Y. And then I'm going to keep the and in between them. Maybe I'll type this out since this is looking so messy. Okay, so we distribute the not and then make it an and in between. And then from here, if we just sort of read this, we have to have X and Y and not X and not Y. Okay, so basically the answer to this is like always false, right? There's no way to have both X and Y true and both X and Y false, right? That's what this says, X and Y both true and X and Y both false. That can't happen, right? We could generate the truth tables to see that that's true, but basically they can't both be true and both be false, right? That just doesn't make any sense, right? So that can never be true together. So that one's false all the time. All right, that's it. These are pretty tricky, but you kind of got to reason your way through them, apply properties when applicable, and then just kind of, if you're really stuck, you could always make a truth table. But I sort of just reason my way through them. So that is all. Thank you for watching.